Cool. All right, so I have quite a few slides, so I figured we'll start a few seconds earlier. So Confessions of a Ruby Developer Whose Heart Was Stolen by Scala. So this talk is mainly about, so a little bit of background. I've been a Java developer for about 10 or so years, dabbled in Ruby for a couple of years, and for the past 6 months I've been using Scala professionally at work. And while this talk is really about Ruby, specifically going against Scala, I think some of the concepts that I cover are pretty broad and they can apply to other dynamic programming languages like Python or JavaScript. All right. So a little bit of background. I'm a developer, Scala developer at Quantifine over in the Bay Area. We do predictive analytics, machine learning. So we're pretty much all Scala and Spark. I'm the author of Redis failover RubyGem that provides automatic failover for your Redis instances that sits on top of Zookeeper and actually relies heavily on this guy right here, his Zookeeper RubyGem. You can reach me there. No, it simply wouldn't work without his gem. So I want to start out with a quote. It's sort of a long quote, but this is by Charles Nutter, which is the JRuby lead developer. So let's just read it. He says, Ruby and JavaScript are dynamically typed, and types and objects can change shape at runtime. This is a confluence of all the hardest to optimize language characteristics. In both cases, the best we can do is to attempt to predict common type and object shapes and insert guards for when we're wrong. But it's not possible to achieve the performance of a system with fully predictable type and object shapes. Prove me wrong. This is Charles Nutter, core developer on the JRuby team, so he knows Java inside and out, obviously, and he knows Ruby very well. So it was kind of interesting, too. This is a quote from one of his recent blog entries. So I went around on the Scala IRC channel and chatted with people about this talk and asked for sort of what they thought about it, and they gave me a few quotes. I think there is a threshold beyond which it is impossible to seriously change any program written in a dynamic language. You end up patching around the edges to avoid unintended consequences, and eventually it's a big ball of sticky tape surrounding the original program. Some of you may identify with this. I certainly have. Test, grep, and prayer. For those of you that have written fairly large Ruby systems, you know that you really don't even want to attempt to refactor it unless you have a ton of integration tests and unit tests, right? If you need to do a refactor, you don't have an IDE to help you. There's no type system, so you're pretty much grepping, right, for all the different places where your method was defined, and you just hope that at runtime you don't get a no method error, and there's a little bit of prayer involved. So let's talk about Ruby. For those of you who don't know, it's a dynamic object-oriented scripting language. One of the things that people love about Ruby is that it's extremely expressive, flexible. You can do many interesting things with it. And developers love that, right? There are multiple implementations. There's MRI, which is the MATS Ruby interpreter. That's the C-based version that most people use. There's JRuby, sits on the JVM, and Rubinius, which is has its own C++ VM. So one of the key things to take away from this is that while it's good to have sort of different implementations, and it ends up they end up sort of competing with one another on certain things. It's unfortunately sort of a curse, I believe, in some ways for the community. For those of you that have tried to write Ruby code, it works well in MRI, but because of C extensions and whatnot, it may not work very well on JRuby. The threading models are different. So one thing that I've personally grown to love about Scala is that you go to scalalang.org and there's a single download. There's a single Scala spec. And I've grown to really like that because I know that when I write my Scala code, I'm mainly targeting the Scala language on the JVM. So sort of at its core, right, Ruby has objects, classes, and modules that are used for sort of namespacing, but mainly as a way to provide mix-ins. And it does have blocks, or what we would call in Scala functions, anonymous closures. The collections library does have a few methods that resemble, or that would make you get you to think that there is functional programming at its core. but not quite. I mean, there's an each cons, flat map, filter, but it's not quite how you would do it in a functional language. Flat map means something a little different in the Ruby collections library. So let's look at Scala briefly. As we know, it's an object-oriented functional hybrid. One of the nice things about Scala is that sort of immutability is encouraged, right? You drop into the Scala REPL and you start playing with the collections. What you're given by default are the immutable ones, and then Scala makes you work a little hard to get to the little bit harder to get to the immutable ones, and sort of goes along with immutability being encouraged. Concurrency really is a first-class citizen. This talk really doesn't get into futures or actors and whatnot. There are other presentations that would do a much better job on it. But one of the nice things about Scala is that you really don't feel that concurrency is sort of an afterthought. It really is sort of part of the language, especially with Scala 2.10, with SIP 14. It is really just sort of a first-class citizen in the language, which is a nice thing. The community cares about concurrency. It's statically typed, right, with powerful type inference. One of the things that I really liked about Scala when I first got involved with it is that coming from Ruby, it was welcoming that I didn't have to annotate every single thing. I really have grown to like the type system. And the type system, it's not perfect. Sometimes you have to help it out and specifically annotate certain things. But for the most part, it works really well. And Scala, sort of at the first class citizens are objects, classes, traits, which are also used sort of interestingly as a way to sort of create modules, but I would say more so it's used as a form of mixins and breaking out your functionality. And functions are akin to Ruby blocks, right? So let's dig into the Ruby philosophy a little bit. Programmers should always be happy when programming in Ruby, right? Mats, the creator of Ruby, really wanted to create a language that, first and foremost, developers would enjoy writing their code in it, right? And I certainly felt that way coming from Java, going into Ruby. It definitely, was an enjoyable experience, right? Another major aspect of Ruby is duck typing. You pass some random object to a method, and you really don't care about its type. You just care that it responds to a particular method. So, method could be process, and you really don't care that if an integer has a process method or my own class has a process method. You just know that if it responds to it, you can invoke it, right? It's a very, as I alluded to earlier, it's a bendable language, right? You can do a lot of crazy things. You can sort of redefine class definitions. You reopen them. I'll show some examples of that later. You can sort of inject methods anywhere along in the hierarchy. So Ruby has sort of the way the method lookup path works is it's sort of a stacked system where starts at the very bottom with a singleton class, right? And you can sort of inject methods or behavior anywhere along that chain, even after the object is created. So you can have somewhere in your code, you could have, if this complex condition, let me go ahead and just extend this instance with this module, right? Sounds really cool, sounds great, it's using a lot of Ruby gems, but in large scale Ruby development, I think it can be a curse at times, and hopefully I can convince you of that. So let's look at modules in Ruby versus Scala's traits, right? So as I mentioned, the modules are mainly used as mixins, just like Scala's traits are. Modules are sort of interesting in that they're sort of the key way to group methods that you can sort of inject anywhere along in the hierarchy. Even when you're defining the class, you can include modules or inject them after the fact, at the instance level or class level. It's mainly used as a way to sort of implement cross-cutting concerns, as we do with Scala, right? We like to group our cross-cutting concerns within traits and mix those in. Like logging might be one, where you sort of have a trait for logging, and then you would mix that into your class. Although I think in the Ruby community, I think modules are somewhat abused. In particular with this point, right? So here's an example from my Redis failover gem, right? Not to get into there's not much code here anyway, but the key things to take away is that this is a module that is essentially defining an abstract method, right? Find candidates. So given a group of snapshots for how different Redis node managers, what their view of the world, you could implement a custom strategy here. It's a strategy pattern to figure out which candidate from those snapshots should I select, right? And one thing you'll notice is that the types are buried in the comments, right? Which is quite brutal. GitHub actually they subscribe to a type documentation system called TomDoc, and so if you look at GitHub's projects, they use this notation where they specify the types, and it helps Ruby development because you really do want your types. You really want to know what is snapshots, right? And so that's one thing, right? So the types are embedded in the comments, which is pretty brittle, right? Because if you refactor your method or you introduce a new argument type or you change the type, you have to also update the comments. And comments are pretty easy to get stale, to become stale. There's also no way to really define abstract methods in Ruby, right? So you find this pattern where you're raising a not implemented error. It's sort of really the only way to enforce that you should implement this method when you extend this module rather. So here's a case where I think things get a little crazy, right? Here's Active Record is the object relational mapper tool for Rails. And here's the base class, right? So any model that you create, if you're a Rails developer, this is like your bread and butter, right? Any model that you create will extend from this class, okay? And what they've chosen to do is sort of break out all the different functionality into different modules, right? Which might be a nice approach. The problem, though, is that this is all jammed, right, into a single namespace. And it's quite problematic when you sort of innocently extend from this class and you've got other gems that you bring into your project and they start jamming more stuff into that namespace, right? And it becomes really difficult to sort of find out this method that I'm calling in my model, like where did it come from? Which module? And the difference here between extend and include is that extend adds these methods at the class level and include adds them at the instance level, right? So it sort of further complicates things. So here's an example, right? So in Ruby, you've got 3 different modules defined, M1, M2, M3. You have class A. Your class B is a subclass of class A. It includes 2 modules. It also defines its own method. So here we create an instance, b equals b.new. Then we extend module M3 on it, and we call b.foo, right? So, there are no types. There's no compiler here to sort of help you out. And this is sort of an isolated example, but this kind of thing happens a lot in Ruby code, right? So which foo implementation gets used? This was actually so frustrating for me at some point in my time with Rails and Ruby that I actually wrote this method locator gem that you can bring into the Ruby REPL, and it's sort of just, you give it a symbol, you give it a name of a method, and it sort of tells you where it's located, right? A lot of times when you're working with Rails and you have a bunch of different gems that are doing things like this, you have to ask yourself, like, where's this method defined? I want to look at the source code. So I ended up writing this gem, which really is, in hindsight, it's kind of an unfortunate thing that you have to do that. So Scala traits, right? Never guess where a method is defined. I think this is pretty key because, for those of you that use IDEs, you can pretty much click on any method that's defined, and your IDE, because it understands the AST and the compile time characteristics, it can take you right to that method definition that it's using. And I think that is just, it personally has saved me a ton of time. I think we have better abstractions also, right? If you recall the slide where all the modules are mixed into Active Record base, I think we have sort of better design patterns that we have available in Scala. So type classes, stackable traits, monads, I'll talk about these in future and subsequent slides. One thing that I've grown to love about Scala in the past 6 months is just the type system. I think it's so powerful to take your business model, your domain model, and be able to sort of encode it in types and have the compiler do the work for you and letting you know where you're sort of tripping up. This is just something that you don't have, obviously, in dynamic languages like Python and Ruby, and sort of, so as as your company has new business requirements, new features, it's nice to be able to sort of see where those fit within the type system. And you know, if it doesn't fit nicely, you can sort of refactor your types, and the IDE and the compiler is there to help you do it. And not in a very verbose way like Java would impose it. So let's talk about monkey patching, right? So monkey patching is something that we find all over, right, in Ruby gems and in Rails, and it's sort of become like the de facto way to sort of do things. For injecting new behavior, people like to write brand new functionality, and it's intended to be jammed into that namespace, right, that common namespace. And it usually happens with modules used as mixins, but it can also happen with people just reopening classes in Ruby, right? And as we saw with the namespace becoming sort of a single point of, I guess, collision, if you will, it can also, even though you've compartmentalized your behavior into different modules, they can also conflict with each other, right? We'll see some examples of that. So let's look at a concrete example, storage units, right? So the idea, by default, most languages don't have, you know, these methods, 250.bytes, 1.megabyte. Let's see how we go about, how the two languages go about adding these methods, right? But we want to try to do it in a way that's not invasive. So here's what Ruby does, right? Or Rails, rather. So numeric is the type that all the numeric types in Ruby are their subclasses of. And so Rails just says, well, you know, I'm the only player in the universe. Let me just reopen the numeric class and let me just jam these methods in there, right? And that's where you get all these nice methods like kilobytes, megabytes. But it's a problem, right? What if I want to go ahead and put in my super optimized version of, you know, megabytes? Probably can't get much more optimized than that, but you can imagine where some other library might want to add its own behavior, and it might also want to reopen the numeric class, or maybe even use module mixins to jam it in, right? And you get collisions, and this definitely happens. Not in this particular case that I've seen, but in other gems I've seen these collisions happen, right? So, you know, we really don't talk about monkey patching in Scala, but, you know, I kind of like to think of it that way just because it's so common in the Rails community and for people who are coming from Ruby. So I want to talk about a couple of ways to achieve monkey patching, right, in Scala. One of them is, you know, implicit conversions. It's something that the language gives you to sort of safely do something that we just saw how Ruby does in the previous slide. And the key thing about this, you know, it might be a scary word, implicit conversion, but the key thing is that sort of the compiler is doing the work for you. Only the compiler will only allow you to have one implicit conversion to be used at a given call site, right? Whereas in Ruby, you can have multiple gems or, you know, multiple dependencies that are all mucking with a given type and sort of all trying to add their version of that same method. And you know, what you see a lot is sort of different projects. You know, if you like, so for example, devise is a gem for common Rails gem for doing security. You find that different Ruby gem authors communicate with each other fairly frequently to make sure that they don't step on each other's toes, right? And you know, and you've even seen this in documentation. For example, you know, this gem just doesn't work well with this other gem, or it does work well with this other gem. And it's really unfortunate that there has to be that kind of communication. So here, the compiler just doesn't let that happen. The compiler, if you try to use two different libraries that both want to augment the class with a new method, it'll compile. I mean, it will not compile. So the other nice thing is that the IDE, as they become more and more advanced, they can sort of tell you, like I think IntelliJ underlines methods that come from an implicit conversion or the implicit scope. So this is actually an example from the Twitter Commons Scala library, or util, rather. So the basic idea, right, to kind of go through this, the basic approach is you define a rich whole number, or just an implicit class that wraps an existing type. So in this case, it's a long. And the key thing here is that if you notice, it's a brand new class, right? So the long namespace is not tampered with. we don't sort of reopen the long type and start adding these methods, right? And that's a key thing. The namespace stays clean. So what you do, so I don't know if you can see this code at the bottom, but essentially what you do is you bring in the implicit conversion. So all of Twitter's common conversions, if you haven't seen this library or seen their conversions, I would encourage you to check it out. They have some really cool things, not just for storage units, but for strings and time and other things. So you bring in com_Twitter conversion storage underscore that brings in the implicit. And then what happens is at compile time, when you try to say 1.gigabyte, the compiler actually says, well, hey, wait a minute, 1 doesn't actually have a gigabyte method. So let me search my implicit scope and see if I can find an implicit conversion that supplies the gigabyte method. So in this case, the compiler will see rich whole number because we've imported that implicit. And then the compiler allows us to invoke the method. And it's all compile time, it's all safe. So going back to Ruby, right? Here's an example of adding pagination to your project, which is a very common thing. When you're writing a web app, you want to be able to paginate sort of results coming from a database. So here's how will paginate works. When you bring will paginate when you load it, it goes back to the active record base namespace, which already has 19 or 20 modules jammed into it, and it says, well, I'm just going to add my stuff to it, right? And the unfortunate thing is that, well, what if one day Rails itself wants to add its own pagination and wants to name its methods page, right? Well, then, it just will break this library. So it's sort of a brittle approach. So let's say we have a post class that extends active record base. The basic idea is that it gives you a page method where you pass in a page and you get back that page of results. Key thing here is, though, you can just see how the namespace is, again, sort of an issue. So let's see how we could potentially do pagination in Scala, right? So while we talked about implicit conversions as one way of sort of augmenting an existing type classes is another. Basic idea of a type class is that it sort of classifies types that have common methods. And I'll show an example of this. But the compiler figures out, so basically, we'll see an example, but basically at the code level, you say that this method relies on this other chunk of functionality. And the compiler sort of figures out and discovers how to marry that piece of functionality for this type that needs these methods at compile time and provide an instance of it for you. So I think it's a much safer alternative to Ruby monkey patching when you're adding a new functionality. So whereas the storage types were just sort of adding very simple methods, so one question you can ask is, well, wait, when do I use a type class? When do I use an implicit conversion? And I've started to use type classes for sort of like bulk functionality, not things that are extremely simple like the storage unit, but pagination, for example, could be a type class. And the nice thing is the type class instance sort of lives in its own world, and the namespace is still kept clean from your existing model. So let's see how maybe we could do pagination with type classes, right? So the type class sort of pattern is you first define a trait. So we're going to define a pager trait that will do the pagination, and it's typed. So it will take a model of a given type and a page number, and it will return a sequence of results. And this is simplified a lot, but this is the basic idea. So that's our pager type class. Then what we do is we go into the pager companion object, and we define a default for pagination. So we have sort of a default model pager, and that's where you would sort of do you go to the database and do any default pagination that you would want for a particular model. And so let's look at an example of how we would use it. Let's say you have a process method, takes a model of a given type and a page number, and what you notice here on the right is you're defining your implicit, and you're telling the compiler, you're saying, hey, at compile time, I have a model of this type. I don't know how to do pagination, but I need something that knows how to do pagination. So I need you to give me a pager for this particular type. And the compiler will supply it. If it can't find it, it's a compiler error. But in this case, it can find it because we've put the implicit object, or the type class instance, if you will, in pager's companion object. And so not to get into too many details, but one of the places where Scala searches for implicit definitions is the companion object of your class, right? Of the type class. And so here we can say pager.page and pass in the model in the page, and then we can do something with the records. Now contrast this with Ruby's approach, which is, well, I know you had a nice little model. Let's say we're using Post. You had your business logic is in Post, but I know your business domain lives in there, but I'm just going to jam in some pagination methods. Well, what if page was actually part of my business domain, and I didn't want you to jam in a method called page in my namespace? One of the key things is that pagination is sort of a separate concern here, and it's sort of totally separate from my model. And I think having that clear separation is really important. And I think a lot of wasted hours are spent in the Ruby world with these jam namespace issues. So let's talk about extending core language libraries. One of the things that we like to do is, well, first of all, Ruby's collections library and Scala's collections library both are very rich, right? They have a lot of great methods, but one of the things that we like to do is add new methods to it, right? So how would you go about doing something like this in Ruby, where you want to sort of extend the collections library? At its core, Ruby's collections are all enumerable. That's where you get sort of the map and the filter and those guys. So it's quite common for libraries to sort of augment enumerable. Scala's approach, and I'll show some examples of this, we can use some of the things that we talked about. We can use implicit conversions. We can use type classes. And we don't directly modify, you don't just sort of, Scala doesn't even let you do this, but you don't sort of reopen the vector class or reopen hash map and start jamming in your methods there. So let's look at a Ruby example. Let's say we add an accept method to hash and an underscore method to string. Accept basically does what it says, so it returns everything minus the keys that are defined, and underscore takes a camel case string and returns a snake case. This is how it's done in the will paginate gem, right? So this is the gem that we were talking about earlier, and it actually at runtime says, well, does hash have an accept method defined? If not, let me reopen the class and define it. Same thing with string. Does it already have an underscore method? If not, let me just reopen it and define underscore. Don't worry about the implementation there, but the basic idea is that it's using class eval and respond to basically tamper with those classes, right? And you can imagine if multiple gems are trying to do this same runtime check. So let's look at an example in Scala, right? Two methods that, so this actually comes from work code. We had a need to have sort of a never-ending iterator. So you've got a vector, you want to call cycle, you want to take 10 of those, and you want to just return back that same sequence of numbers. Sample, right? Surprisingly, actually, I don't believe the Scala collections have a sort of a way to get a random sample of elements from a given collection. So I've got, 1,000 numbers there, and I want to just get 5 of them randomly. You can call sample, right? So how would I add these methods? Well, let's look at cycle. We could use an implicit conversion, right? We can create an implicit class on rich sequence. It takes the underlying sequence, and we just add our cycle method, right? And the nice thing is that it's not, it doesn't conflict with underlying's namespace. Underlying is still a separate object entirely. So the cycle method basically converts the underlying instance to a stream, which Scala's lazily evaluated list, and we just attach it back to ourselves, so back to circular. It's a little mind-bending at first, but it basically gives you sort of a never-ending iterator that reuses or recycles the existing elements and doesn't create new, doesn't waste space. So let's look at sample, right? This actually implements reservoir sampling. I'm not sure if you guys are familiar with that algorithm, but it's basically a way to do to get a random sample of elements, right? And we don't have to get into all the details, but essentially the idea is you're looping through each element, and if basically up to k, you're going to seed it with the initial elements, and then as you're visiting the subsequent elements, you basically make a calculation to determine if you need to swap it with a new one. This scales with the size of underlying. There are other algorithms too, but this seemed to work well for us. Just a side note, I originally wrote this with zip with index, and the performance was not what I expected. So I dropped down to keeping track of my own index, and it worked. Okay, it looks like I'm running out of time. So let's look at better abstractions, right? So tail recursive methods, for expressions, pattern matching, custom extractors, stackable traits. So I'll just go over these really, really quickly. What's it? Oh, you were. Oh, sorry. Oh, I thought you said because I'm running out of time. Oh, sorry. Okay. Actually, wait. It's 2 o'clock. Started at 1:30. Yeah. I still have a little time. Good. No worries. So, all right. So let's look at these. So I think Scala provides better abstractions. It gives us some new tools, some new toys to play with for modeling our code, right? So these are just a few that I've grown to really like. Tail recursive methods, for expressions, using partial functions and pattern matching to model behavior on stackable traits. Let's look at a tail recursive method. So let's say that I have a collection and I want to sort of group the common elements, the common run elements. So I think this is commonly called like group runs, or there may be a different name for it. But sort of a nice way to model this, right, is to use a tail recursive method. So the idea is that you handle a base case. So what do I do when my sequence is empty? I just return my currently accumulated list of results. Otherwise, I just think of the world as just being that current iteration, and I find all the elements that are common with each other, and I use span for that, and get the remaining elements. And then once I have that isolated iteration, I don't have to worry about sort of other state tracking variables and while loops and all that stuff. I just call myself again, right, with the remaining elements and appending that current calculation on the accumulator. So I find tail recursive methods, I usually strive to write tail recursive methods before having to drop down to a while loop. So for expressions, right? There's a lot of code on this slide. But so for expressions, I really like because it sort of helps you model your business logic or certain flows in a really nice way. So let's say we've got a text file on disk, a really big one, and it has records in it. In the records, it has a blog URL, it has a user ID, it has a post ID, and I just want to parse these records, right? And I want to do something. So actually, if you just jump down to the bottom, this is what I'd really like to do. I'd like to say parse records, pass in the file name. I'd like to filter all the ones where the user ID is Ryan, and then just take 20, right? But I want to do that in such a way where I don't have to load the whole file in memory, and I want to be able to use the nice collections libraries to be able to do that. So let's look at parse records. It's a for expression, and so we read the file, source.from file, and getLines returns an iterator, but I call toStream on it, right? And the way that this monadic expression works is my final result of the method of the for expression is going to be whatever type it is of the first guy. So I call toStream on that. Parse the line out. I may have some malformed records, so I just want to filter those guys out, and that's what allCatch.opt lets me do. If this guy throws an exception there, it'll just truncate the for comprehension. I might have some empty text. I want to ignore that. And post ID and user ID may be missing in some records. So only if all of these conditions are satisfied do I want to yield the result, yield the record. And because it's lazy, this for comprehension is actually not executing. It's not progressing through all of the individual records in the file. And so that allows me to say parse records. I get back a lazy stream. I filter all the ones that I need. It's a case class, so I can use the filtering there where it's from Ryan, and then I take the 20 records. And the nice thing is that there's really not a lot of magic in the for expression. It really just relies on filter map and flat map, which you can use in your own code. So an example of pattern matching and extractors. So the basic idea is that you have filtering code, and you want to sort of write it in such a way that it's reusable across many different parts of your code. And so the basic idea behind a custom extractor is it takes a value. So in this case, this is sort of kind of related to Redis failover. But let's say you have a bunch of nodes that you want to figure out which ones are reachable. So I can say, well, reachable, which takes a node and returns an option. So if it's seen by a certain amount of other nodes, then I'll actually return some node, which means that extractor will evaluate properly, otherwise none. So I can use this, right, with collect first. Collect first takes It's part of the standard library. It takes a partial function, and so I can use a custom extractor. So I can just say, well, nodes collect first, so stop at the first node that properly evaluates my extractor and return the address of that. And yes, you could bury this filtering code within an actual filter if you wanted to, but the nice thing about breaking it out into an extractor is that the logic is reusable. So let's look at stackable traits. This is an example from Scalatra, which is an open source project that is like a Sinatra, which is a Ruby project, but for the Scala community. So the basic idea behind stackable traits is you defined an abstract method in your base trait. So in this case, handle takes a servlet request, servlet response, and it's up to you to define the implementations, right? So these are abbreviated versions of the ones that Scalatra has, but they provide gzip support, SSL requirement, which extend handler. And the key thing about stackable trait is you see this abstract override. This is sort of the key pattern, abstract override, and you do whatever business logic you need, and then you just delegate to someone above you. And you really don't know who is above you, but you know that you can safely call super.handle because you're extending handler, right? And so this is really nice for sort of pipeline-based designs where you have this sort of flow, and in each part of the pipeline you want to put certain business logic, and each isolated part of the business logic pipeline shouldn't know about the other. And this was the design pattern that they chose, right? So when I write my own service, I extend a base type, Scalatra servlet, and then I just list which traits I want to be stacked onto me, essentially. So if I need SSL, I do that. If I need gzip, I extend the gzip support trait. And the cool thing is that my business logic is totally unaware of the logic that the traits are sort of injecting into me. So sort of switching gears and looking at refactoring between the two. So as developers, we spend a lot of our time refactoring. Especially in startup companies, the business requirements are constantly changing, and I think it's really key that the code sort of keeps up with the business vocabulary as the business is moving forward, right? So that often translates into like refactoring components. We call this thing one thing, but the business decided it's something else, and for us to keep our heads straight in the code, we really should refactor it to be this. And so we spend a lot of time refactoring. And I think it's very important to be able to do this very quickly and easily, especially for larger code bases, so that you just don't incur technical debt, right? And in my experience with Ruby is a lot of times the larger Ruby code bases, it's hard to refactor them, and so you get a lot of technical debt. Especially if you've brought in certain gems and you've monkey patched those gems, or they've monkey patched you, and so it's really hard to refactor them. So I would only refactor in Ruby if I had a ton of integration tests, because without them it's really hard to know without the type system if you're actually doing a good job of it, right? And as the code base gets larger, it's hard to write these integration tests. And unfortunately, this has happened to me a few times where we did a very large refactor, didn't have as many integration tests as we had hoped, and bam, some crazy condition in production yields a no method error, just because you don't have the compiler to help you. So the key thing, we've talked about this before, in Scala, the type system is rich. We should use it because it helps us. The compiler always helps us for doing large refactors. The nice thing is, immediate feedback. If I botch a parameter in my type class, for example, or botch a method definition, the compiler is going to let me know immediately, and I just don't have to sit there and wait for all my unit tests to complete. I found that, so when I started with Scala, I started using Vim, because that's just typically what I would do in the Ruby world. But I've actually grown to love the IDE for one particular thing that I always wanted in Ruby, right? In Ruby, a lot of times you're in someone else's code, or you're in your own code, and you're trying to figure out what's the type of this particular variable. And it's really hard to know that unless you do something at runtime and print out the type. So here's an example. We're actually, at Quantifying, we're pretty big committers to the Spark project, which is Hadoop-like, but it's completely written in Scala, and I encourage you guys to check it out if you haven't. But we're actually in the process of making an addition to Spark for the way that it does its accumulators, which is a way in Spark to sort of accumulate a value over multiple nodes. So in this particular piece of code, right, like it's a 10% project, so we pretty much only work on it every once in a while. But just going back to this code weeks later, in the IDE, I just hit Command T on this object here, and I get the type. I mean, I knew that merge lock was a reentry lock. This is just an example, but you can see how this is extremely beneficial for large code bases and exploration of new code bases also. So, conclusion. This is my opinion. You may disagree, but in my opinion, Ruby is great for small-scale development. I think so. If Ruby's goal is for you to be happy when you're developing, I think you will stay happy if you're writing code in the small scale. As we know, building complex systems is very challenging, and doing it in a dynamic language is extremely difficult. That's from trying to manage sort of a large open source project and at previous companies where I was using Ruby. This is something that I kind of sadly realized because I really liked Ruby, right? I mean, I thought I was very productive in it, but I just think it's too easy for you to shoot yourself in the foot with it. And I think Scala is a great middle ground, right? For reasons for type, the things that I've shown here, type inference, all of those nice things that kind of trick you into thinking that you're writing in a dynamic language, I think really allows you to use Scala at the small scale and large scale. And I think Scala will keep you happy for small shell scripts and large, big complex systems. I should also mention, 2 seconds, I work for Quantifying. We're hiring Scala developers. If you're interested in data science, machine learning, using Spark, all that stuff, catch me afterwards. That's how you can reach me. Thanks. I think we're like 5 minutes early if anyone has, cool.
How are you finding speed? So big Ruby Rails, I can go really fast at the beginning.
Mm-hmm.
I'm finding the same thing in large code bases, like I tend to slow down. What do you think the speed hit early on in Scala is, or if there is any? If there's
right. Like speed,